Good day, everyone, and I'm happy to present you our research on sustainability and reliability insurance models for automated technological systems in chemical industry, systemic ergonomic approach. Our research was carried out within the framework of the scientific school of Professor Anatoly Gubinsky, our teacher, and we want to dedicate this report to his blessed memory. The problem is that in complex technological chemical systems, the risks of accidents and danger to human life and health increase. The probabilities of environmental problems are very high. Here you can see the sad statistics of accidents and deaths of people. Often the causes of accidents in such systems are human operator errors. This is not surprising. People often work in conditions of great tension, and are exposed to different stress factors. To ensure the reliability of the human operator, an ergonomic support system is needed. This problem is very important. Ergonomic support tasks are being developed by scientists from many countries. Most ergonomic research focuses on physical or cognitive ergonomics. Existing methods poorly describe the logic of human-machine interaction. Therefore, it is very difficult to study the reliability of activities and develop a system to improve the interaction of man-computer. A large number of scientists are studying the optimization of human-machine interaction. Among the known theories, the functional structural theory of ergotechnical systems is the most convenient. This theory was developed by the scientific school of Professor Anatoly Gubinsky. The advantages of the theory are ability to formally describe the activity algorithms, and ability to estimate the reliability of activity. The theory uses a model called a functional network to describe the activities of a human operator. This is a very useful way of modeling, but we have great limitations in the application of the model. The main limitation is the lack of opportunity to automate estimation of the operator reliability, optimization of operator activity, and selection for improvements. Thus, there is a need to develop new models aimed at ensuring the maximum probability of error-free performance of activities, as well as the implementation of ergonomic standards and requirements. To estimate the reliability of the activities of operators, typical functional structures have been identified. There are 22 such structures. Here you can see a few examples. For each typical functional structure, we developed models to estimate the probability of error-free performance and activity execution time. To estimate the reliability of the operator's activity, it is necessary to carry out several stages of the functional network reduction. At the same time, it is necessary to find typical functional structures and use mathematical models to calculate reliability. For an effective and rapid estimation of the operator activities, it is necessary to make the process fully automatic. This requires a convenient description method for the functional network. Due to this, we developed a method for describing a functional network, a method for finding and recognizing typical functional structures, and a method for reducing the functional network. Here you can see an example of the activity algorithm description. Such descriptions are generated automatically, and the ergonomist only answers some questions about the structure of the activity. The method of description is convenient in order to carry out the recognition of typical functional structures and its reduction. We also developed a special software that allows us to estimate the reliability of activity. Automatic reduction and analysis options are provided. The information system we present also provides convenient interactive input of information on the structure of activities, formation of a database on operator reliability, automatic analysis of activity structure, automatic assessment of the reliability of operator activity, activity algorithm optimization, and finally transferring the results to the database. Thus, the system provides a quick assessment and analysis of options for human-machine interaction. Here you can see examples of formal models for the real technological process of manufacturing NPK fertilizer Super Argo and the content of the actions that an operator must perform. The software conducts an automatic estimation of the reliability of activities, and one can see an example of the estimation of process. Here we present results of the estimation and the different options for structures of activity and results of the assessment of such activities are given on the slide. Thus, we compare different options for the structure of activity. In the case of a large number of options, an optimization problem should be posed and solved. It is convenient to formulate and solve the optimization problem if we go from the work graph to the event graph. Events consist in performing operations with or without error. So this model is semi-Markov decision-making process. It is necessary to ensure the maximum of the process getting to the vertex number 1. Thus, we can present the optimization problem in this form. Here is an example for solving a problem for optimizing the operator's activities for the technological process of manufacturing NPK fertilizer Super Argo. Solving the problem maximizes the probability of error-free execution and satisfies the constraints on time and resource costs. We would also like to briefly talk about another important aspect of the operator's activities, the quality of the interface, which has a great influence on the quality of control of production process in the chemical industry. Therefore, we had to develop a special methodology for assessing and certifying interfaces. The logic of the system is presented to you on the slide. So our main results are the method for evaluating and optimizing production process in the chemical industry, which is based on a single model that describes the actions of man operator and the functioning of a machine and allows to solve the main task of ergonomic design. In order to actively use the developed models in ergonomics, it is necessary to expand the concept of method of performing an operation and take into account all the factors that determine reliability for a human operator. Design features of workplace, interface features, the intensity of activities, operational functional states, and so on and so on. The developed models have been widely tested and can be a convenient tool for managing reliability and ergonomic quality. We analyzed the existing problem and identified our tasks for the future. They are associated with the use of artificial intelligence methods and convenient methods of input and analysis of human-computer interaction. Thank you very much.